ocean floor map of the U.S. Navy Office of Naval Research. And this map shows that the Earth has split at the seam, and the split occurred at the current position of the Dead Sea, went down the Red Sea into the Indian Ocean, and then forked. One part of the fork created the Atlantic Ocean, and the other part of the fork created the Pacific Ocean. And the stretch marks, although you can't see it too well in this picture, or some of the later pictures will show it better, the stretch marks extend basically from the edge of one continent to the edge of another. And so this is not plate tectonics where you have a constant size Earth and the plates are moving. This is three-dimensional expansion. It is this expansion marks are the largest structure on the whole Earth, and they dwarf the size of all the continents, because continents only make up 1/7 of the surface of the Earth, and these stretch marks make up most of the surface of the Earth. And so it's the evidence that the Earth is expanded, and if you model this, you find that the expansion's been approximately 70% from before the time of the flood. If we go to the next slide, this is the graph of the people who believe in plate tectonics. And I want to show it doesn't support plate tectonics with a constant size Earth. If you now look at this map, which shows the mid-Atlantic and the Pacific ocean ridges, and the direction of the motion of the plates on each side of the ridge, you will see that in the Atlantic Ocean, the plates are moving away from each other. In other words, South America is moving away from Africa. If you look at the ridge that goes and forms the Pacific Ocean, you'll see that both sides of the plate are moving away from each other. There is one part on this map where the two are moving together, and I'll explain what that is in a moment. But if you remember from the map, there's the big expansion marks are following all of the ridge lines that are moving apart, showing that the main motion is three-dimensional expansion, not plate tectonics where one plate is moving under another plate. Now, I'll explain why it is we have this one place where it appears there may be plates moving under a plate. And the reason for that is, as the Earth expands and gets bigger, it has to conserve angular momentum. So some of the continents cannot keep up their velocity. They have got to slow down. And when they slow down, the plate they're on runs underneath another plate at the weakest place on the Earth. And so the eastern side of Asia is where the weakest place is, on the edge of the largest ocean, the Pacific. And there you see that part of the ocean plate is going under the continent because it has to conserve angular momentum. And it has to slow down, and some part is the weakest part, will have to slow down. You can see that this is what it is because the part that is undergoing subduction is in an arc. And that arc is due to the slowdown in the rotation rate of the Earth. So as the Earth has expanded, its rotation rate has to slow down. And some part of the surface of the Earth has to give way, and that's where it was. So anyway, even the data from the people who believe in plate tectonics does not support their model. There are plates, though. Even on this three-dimensional expansion, the continents do form plates. So there are actual plates, but it's not a constant size Earth. And this idea of subduction, that you have a constant size Earth and the various continents are being recycled, that's not valid. The next slide. This is the NOAA Sandwell-Smith satellite map of the bottom of the oceans, and it also supports this data. By the way, the first data, the one from the Office of Naval Research, is from the sonar logs of ships who've made trips across the ocean. You get your coordinates, and then you do your sonar, and you get how far it is to the bottom, and from that they were able to construct a map of the bottom of all the oceans. And so this one here from satellite turns out that there's structure on the bottom of the ocean. That structure is reflected because the water is moving in the height of the water in the ocean. And from the satellite, you can measure changes in height of just a few inches. And so you can see the structure on the bottom of the ocean on the surface of the water. And that's what these maps were able to confirm exactly what the ship logs had said earlier. Next one. This is the stretch marks of the Earth's expansion. This is a close-up of that map by Office of Naval Research. And first of all, this is a beautiful map. I want to show you what you can see. Can you see the detailed structure between Africa and South America? You see these are mountain ranges, big mountain ranges that are going from the edge of one continent to the other. Do you see where it's kind of a bluish color around the edge? That is where silt has filled in these stretch marks. Silt from the flow of sediment down rivers around the edge of the continent, and from the flow of currents in the ocean. And so what you see is the amount of silt, it's only at the edge of the continent. It's not in the center of the oceans. If the division of the continents had occurred during the time of the flood, there would be as much sediment in the middle of the ocean as there is on the continents. And on the continents, we have over a mile deep of sediment. But we don't have much sediment at all in the middle of the ocean. Most of the sediment is around the edge of the continents. And, of course, after the flood was over, the sediment was very soft on the continent and could erode quickly at first, and then over time became harder and eroded more slowly. So, anyway, we see wonderful evidence, and from this you can see a little better the path of the stretch marks for three-dimensional expansion. And by the way, the Dead Sea is a unique spot on the surface of the Earth. It is the lowest spot below sea level. They're over 1,300 feet below sea level on the surface of the Earth. It's above water. And not only that, it is within sight of Mount Ararat. And so Noah and his descendants would have seen the land that used to be where the Dead Sea is now sink. And they saw the division start there, and they could see it going down toward the Red Sea. And that's why Peleg was given his name, because they saw the division of the earth. Now, they didn't see all the way through the formation of all the oceans and all that sort of thing. All they could see was this splitting near where they were living. Any questions on that? Okay, the decay of gravity is following some kind of curve, like an exponential or some type of decay curve. All right, and it's getting slower. The decay rate is getting slower over time. The surface of the Earth is made of material that is elastic. Now, you know, I can take a balloon, which is elastic, and I can blow it up. And so basically the Earth is slowly blowing up. Now, when I blow up a balloon, it can expand a certain amount, probably more than the Earth, before it pops. Okay? So what happened in the case of the Earth, it didn't pop. It expanded before the flood, and it expanded because it was elastic. But it reached the limit of its elasticity. Anything that you bend or stretch has a limit, and at that point it will crack or break. So what happened is the Earth slowly expanded, and then at one point it cracked. When it cracked, the water that was held beneath the surface of the Earth, because God caused the firmament to divide the water to waters above and waters below, that firmament cracked and allowed the waters under pressure, because it was even though it's elastic, it's not perfectly elastic. It takes force to stretch it. So it was under force, and it escaped because of that force and burst out because it was under a lot of pressure, and it came to the surface. And when it came to the surface, it lubricated the cracks that were there, which made it easier for the Earth to split and come apart more. And so it did. And so the Earth was under a lot of force at the time the flood began, and some of that force got relieved by the Earth expanding more rapidly, because now it was no longer expanding elastically, it was expanding by cracking. And so the crust was. And so the Earth expanded larger, so after a year or so, the water began to recede because the Earth was expanding fast enough that the highest mountains no longer were covered by 25 feet or whatever of water. If the Earth expanded by just 1%, then the water would recede down the mountain. And so the elasticity reaching its limits allowed a faster expansion per year at the time it cracked. And the lubrication helped, and but as the Earth finally really did its big expansion 100 years later, when it expanded 70%, not 1%, 70%, and we see these giant stretch marks from that expansion. And that expansion is still going on. It hasn't stopped. We don't know if all of the 70% occurred 101 years after the flood, or it's just been continuous ever since then. But we know it occurred after the flood because we don't have all this sand and sediment in the middle of the ocean, where it would be if the expansion had occurred at the time of the flood. Now I want to go on to some more proof. If the decay of gravity is valid and the Earth expanded, then every planet, every moon in our solar system should have done the same thing. So let's take a look. The next slide shows a picture of the moon. The moon has mares or seas. Now we saw that the origin of the seas, they're above the giant stretch marks on the Earth. And that is where the water settled for the seas. Now, on the moon, they didn't have any water, as far as we know, at the time that it expanded. And so all we had was lava, and the lava was molten. And so the seas are just flat spots on the surface. And if you look at this picture of the moon, where the dark flat spots are, the mares, that is where the moon has expanded, and where the white part is, that's where the continents are, if you want to say it that way. And so we see that the moon has also undergone a significant expansion. Now the moon is smaller than the Earth, and so it may not have expanded as 70% expansion may not show up as big a deal on that planet. If we can now go to the next slide. This is a picture of Jupiter's moon, Ganymede. It didn't have any water, and Ganymede cracked. It didn't pull apart quite like some of the others, and so it looks like a piece of pottery cracking. You can see where lava came up between the parts that cracked due to the three-dimensional expansion. If we look at the next slide, this is a picture of Jupiter's moon, Europa, and it is a bigger planet, and you can see it is in the process of expanding now. You can see the surface cracking, and you can see lava coming out all over the surface where it's beginning to crack. If we look at the next slide, this is a radar image of Venus, and Venus, this is temperature on the surface of Venus. Venus is undergoing major expansion. You can see where the hot parts are, and you can see the expansion. The cooler parts are blue, and the hot parts are yellow and red. And so we see that Venus, underneath that big cloud cover, is undergoing major expansion right now. And you can see all the hot lava and everything coming out in copious quantities, kind of like we would imagine might have occurred under the water when the continents of the Earth expanded. The next next planet is Mars, and we can see a giant expansion crack here. But Mars also has seas and continents, so we see two different types of evidence of expansion in the case of Mars. Okay, so now the next slide. We'll go to the next slide.
Dr.
So now,
Lucas, I just had a random thought, and I just wondered if this has occurred to you, but could it be that the expansion of the Earth could give us some sort of an explanation to Joshua's long day?
I'm getting to that. Oh, long day.
Well, just conservation of angular momentum would require, if you got a larger radius, it's going to take longer to go around, and you'd have a day that was longer.
Those are some possibilities. I hadn't thought about that, but if a lot of the ocean slipped under Asia at one point, it could be that the Earth didn't rotate at the same speed it is now. It stopped rotating while that was happening, or something along that line. That's a possibility. But that would produce great earthquakes, I would think. I don't know if there was. Of course, that's a long way away from where Palestine is. But those are interesting thoughts. I haven't tried to explain that. I'd always thought that maybe the breakup of the asteroids. There was a planet there at one time. The breakup of that might have caused a disruption in the orbits of everything temporarily. But I don't know. I really haven't had a chance to think about that too much. Well, that's a good thought. Okay, now I want to talk about if this idea of the expansion of the Earth is valid, then something is going to happen to the atmosphere of the Earth. The atmosphere of the Earth is going to get thinner. If the Earth has expanded 70%, which is what it appears from the expansion marks that we saw on the bottom of the ocean, then it turns out the surface of the Earth is going to be much larger, and the density of the atmosphere is going to be approximately 1/9 what it was before the flood. And so there's all kinds of effects that will occur. Now, if you look at aging, then we know from your cells in your body that the way they age is they age by reproducing, and that there are telomeres, little caps on the DNA of the molecules, the DNA molecules, and these telomeres determine the number of times your cell can reproduce before it dies. And we know that cosmic rays coming into the Earth destroy some of the telomeres and reduce the number of times that the cell can reproduce. Assuming that the cosmic rays have been constant over the history of the Earth, which may not be true, and that the only difference between the time before the flood, when people lived typically to be 900 years of age or older, and today is just the thinning of the atmosphere, then we would expect, if the atmosphere is 1/9 as dense and thick as it used to be, that the rate of destruction of telomeres would be 9 times greater, and that the maximum age of man would be approximately 1/9 what it was in the days before the flood. So that says the maximum age would be a little over 100 years today versus before the flood. And we only know how much the Earth has expanded since the flood. We don't know how much it expanded before the flood. So we could be off a little bit there. But anyway, that's a general idea, and it seems to fit with the fact that many people live about 1/9 as long as they did in the Bible before the time of the flood.
Dr. Lucas, you said earlier about the expansion, when the continents divided, happening 100 or some period after the flood.
Yes.
It was at that instant that the aging stopped. I mean, the people stopped living. I mean, Noah lived to be quite a bit, several hundred years after the flood. It wasn't immediate. It was a few hundred years.
Right, right, right. So he probably aged faster, died a little quicker than he might have otherwise. Uh, yeah, that's true. And there is after the flood, some of those people had a fairly long lifespan. Um, I haven't plotted them all, but uh, it's uh, uh, it's still hundreds of years. It's not down to 120 or whatever. It seems to become the maximum age not too long after that. Okay, the next slide shows a picture of these telomeres and the DNA molecule. You can see the caps.
Dr. Lucas, does that mean you could potentially plot the length of long people lived and then perhaps correlate that with the expansion of the Earth?
That's a possibility. Yeah. One of my relatives, one of my in-laws, has published a book where he has done some of that, but not due to this effect, just due to gene pool mixing. He has two gene pools in Genesis, one short-lived and one long-lived, and he showed the gradual decline, and he had a lot of data in his book, which I have a copy of. I could look in there, but that's a possibility, yes. You'll see some more things here in this that are related to that, too. But, okay, so lifetime would be shorter due to the cosmic rays being more reaching the surface of the Earth. The next slide, we talk about disease. Now, in the Bible, there is no mention of disease before the flood. No mention of people being sick. And why is that? Well, is there a natural explanation for that? If the atmospheric pressure were higher in the past, then the pressure of oxygen would be higher. And today, my daughter works at Johns Hopkins University Hospital in Baltimore, Maryland, and for people who are really bad off, that they may not live, they have what's called a hyperbaric chamber. And what they do is they put 3 times the current atmospheric pressure in them of just regular air, and they find that they can recover from illnesses, diseases, and surgeries that they might not have recovered if they hadn't been put in there, just due to the higher pressure. And many diseases you can recover from just by being at a higher pressure. And so that may explain why they didn't have disease. Disease came about as the atmospheric pressure lowered. And that's why the continents of Europe were devastated when finally disease started hitting them, and they had the plagues and everything. And the Roman Empire fell to the barbarians because 9/10 of the population had died due to plagues, and there wasn't anyone to resist the barbarians coming in. And populations of big cities like Rome and Paris dropped from hundreds of thousands to 10,000, and they just couldn't maintain that. So anyway, that can describe why there was no disease until after the flood. The next slide is a very interesting picture that I found on the internet. These are the heights of the largest human skeletons that have been found. I didn't know of any larger than 13 feet until I came across this slide, but these are all fossils that have been found. The largest human fossil skeleton is 36 feet high. Just as we have in the fossil record large dinosaurs that were huge, we also have humans that were huge. And these were not monkeys. These are humans. And I know where one of them came from, and that is in the one of the Roman historians has the account of when the Roman Emperor Hadrian conquered Israel. I don't know if you remember, Israel was conquered and overthrown by the Romans in 70 AD, but they rebelled. And they rebelled in what's called the Bar Kokhba War. And they managed to take over Jerusalem and even Byzantium. and a number of the cities there, and the Romans came back and reconquered them after about 3 or 4 years. And when they did that, the Roman Emperor Hadrian was bragging to the rabbis there how powerful he was. And so the rabbis took him to a cave in the area where the Amorites had lived. And in this cave, they had a number of Amorite skeletons. And he showed them skeletons where the men were 30 feet in height. And he told Hadrian that when the Jews were in good relationship with God and not sinning, he allowed them to conquer these giants. But now that they had sinned, God had allowed the Romans to conquer them, but the Romans could not have conquered these giants without God's help. And so that's where some of those come. Some of those are from the Amorites, but they come from various continents of the earth. Some of them come from the United States. And so we see that people live larger in the past. Now, how can that be? If you're a structural engineer and you look at the strength of the muscles in the heart and the height they would have to pump blood for a person that size, with the current density of oxygen, it is impossible, structurally speaking, for our heart to support an animal 36 feet high. But with much higher oxygen density, it wouldn't have to work as hard, and so it could do it. And so what we find is that the larger size of animals in the past is consistent with an expanding Earth and a declining atmospheric pressure. The next slide shows a picture of a fossil dragonfly. You know what a dragonfly is. This fossil is 30 inches from tip to tip of the wingspan. Now the next picture shows you what it might look like on a tree. And so we see that not only did animals, but also insects, everything was larger. Now, the way the insect breathes is through the trachea, and it doesn't have a heart, quite like we do. And so it, again, structurally is very limited. You couldn't get a dragonfly this size unless you had a higher density of oxygen to support the insects. And we find many large insects in the fossil record. Now I want to go to the next slide and talk about the problem of starlight. If you look at the upper graph picture I showed you of the cosmic background radiation, you see that the cosmic background radiation is very uniform throughout the universe. And we're showing it, we're plotting it here on the maximum extent of the universe, the surface of the universe that we can see. If and the current notion from many astronomers that the universe is 15 billion light years in radius. That means the diameter is 30 million light years, and in order for the light to come to equilibrium from one side to the other, it has to have reached and had a chance to come to equilibrium. And so we see it is in equilibrium, but it is impossible for it to have come to equilibrium in 15 billion years. Even in 30 billion years, it doesn't have enough time to really come to equilibrium. It has enough time for light from the most distant stars to reach each other, but the only explanation for how it could possibly be in equilibrium is that the Earth, the universe is expanding. Of course, the Scripture says that it is expanding, and that God did it by His discretion, and that it appears He used some kind of process, and it's continuing to expand over time. So that notion is consistent with the cosmic background radiation, and it is not consistent with the notion that that light took that many years to get here. It depends on the rate of expansion and many other factors, whether the velocity of light is the same at the edge of the universe as it is here. So there's a lot of assumptions here, but there's an inconsistency in the starlight horizon problem that the Big Bang model cannot deal with. I want you to see that. Let's go 2 slides. There was a question about how far away are things. This slide shows the astronomical methods for measuring distance. Okay? The first method is parallax. You see it's good from 1 parsec, which is 3.2 light years, up to 100 parsecs. So it's 300 light years. We use the parallax method. We think that method is accurate because it uses just regular geometry, but it can't measure beyond that. The next method, which is totally independent of that method, is the cluster spiral galaxies using the HR diagrams. And we showed that a lot of that data is explained by a little bit different theory than they're using, but they claim there's a little bit of overlap here, a few stars at least, between that method and the parallax, and they think that it's an accurate method, and it takes you up to 30,000 light years. And then there's another method involving supernovas, and you can see it overlaps a little bit with the cluster HR diagram, and then there's the method of Cephids or variable stars, and you can see it also overlaps. Well, these bottom 4 indicators are considered the least shaky of the methods for measuring distance. Okay? And there's very little overlap with the one reliable one, which is parallax, and the theories of what's going on and what you're observing here. These are usually interpreted in terms of general relativity, special relativity, etc., not in terms of our universal force law. So we haven't gone through all of them yet. We see that we can explain the phenomena that they're explaining. We explain it a very different way, and we suspect that the distance that we're seeing may change. In other words, instead of being able to measure things out to more than 3,000 million, I guess 3 billion years or more, 15 billion years of distance, light years, we may find that distance collapses when you now look at the proper theory that explains the phenomena that you're using to do these measurements. Like you can see the Tully-Fisher relation, we explained that. We didn't go into supernovas and some of these other phenomena. But what I'm trying to say is, if any one of these blocks fails or is reinterpreted, it may change the whole scale. So I wouldn't put a lot of stock in those distances, and also if the velocity of light at the edge of the universe, which is farther away, we're fairly near the center, if the velocity is much higher there, then those distance objects are, in terms of the light years we measure on Earth, they may be very few years of distance at the higher speed that they go. So anyway, that's the idea. We have a lot of unknowns, but that distance measuring is on very shaky ground. Once that universal force law is accepted, and you now have to throw out the special relativity theory, you have to throw out general relativity theory. So a lot of these theories depend on those, and they depend on these phenomena that's going on that we've already explained another way. So I just want you to see that. If you go to the next slide, this shows the Hertzsprung-Russell diagram, which shows the sequence that is assumed that stars go through. The stars, when you plot them by luminosity versus temperature, you see that they're not evenly distributed everywhere. They're in 4 groups, and then most of them follow on what's called a main sequence of stars. And it's assumed that the stars are moving down this sequence over time, over billions of years. But it may be that we're just seeing different phases, and all the astronomical bodies were created at the same time, and we're at different distances from the Earth. We're just seeing the different phases as we look back in time. So anyway, there's a lot of interesting information. But what I want to convey to you is, it looks like this new theory of gravity is able to explain so many more phenomena than any previous theory, that all the conclusions that have been come to may be done away with as we reanalyze this data from this new approach. We know we can explain the phenomena that's being seen, we just haven't interpreted in terms of distance and age and that sort of thing. Okay, this next slide shows one of the techniques where you look at that from different distances from the Earth. You see different HR spectrum lines for the decay of one stream of stars, and you can, by comparing the distances between them, you can determine how much further away they are from a number of phenomena. Okay, I'm run out of time. Let me just go to the first red slide. There's a couple slides beyond here. This talks about the destruction of the earth by fire. This is from 2 Peter 3. It says, first of all, you must understand this, that scoffers will come in the last days with scoffing, following their own passions, and saying, where is the promise of his coming? For ever since the fathers fell asleep, all things have continued as they were from the beginning of creation. They deliberately ignore the fact that by the word of God, heavens existed long ago, and an earth formed out of water and by means of water, through which the world that then existed was deluged with water and perished. But by the same word, the heavens and the earth that now exist have been stored up for fire, being kept unto the day of judgment and destruction of ungodly men. This word we equate with an emanation from God during the creation week. And so when God created the earth and it started to decay by gravity, it appears that all these things were scheduled, including this final destruction of the earth. And so it may be possible to get some idea of when that will occur from the thinning of the surface of the earth and from the thinning of the atmosphere, so that the sun heats the earth up more. And of course the sun is getting bigger every year as it grows in size, and due to the fact that it's not held as tightly together. And so all these processes are going on, and we don't know when that will be, but it should be possible to model it. And it looks like it is scheduled from the phenomena that we understand. And then in 2 Peter 3:10 to 13 it says, the day of the Lord will come like a thief, and the heavens will pass away with a loud noise, and the elements will be dissolved with fire, and the earth and all the works there are upon it will be burned up. So that seems to be consistent with this decay of gravity. So we see a number of phenomena in the Scripture that look like it can be tied to this view of gravity. This view of gravity is tied to a universal force law, which is electromagnetic force law, which appears to be identifiable as a divine force law, and the mechanism by which God did everything. And so we think it is a marvelous evangelistic tool. When I was in Ukraine, I spoke in 60 different places and used this type of message as an evangelistic tool in a society that had taught evolution only for 80 years. And they came out in large numbers to hear this. And so it's a real possibility for us. And as Christians, we lose our credibility of our message if we have the public school systems teaching these theories which are false, which deny what the Bible is saying. And so we need to be more active. We need to ask that these false theories be removed from textbooks that are unsupportable, and get more supportable theories put in textbooks. At this point, I will stop and take any final questions you might have.
I got a question on, I read about the sun shrinking and getting smaller, and then what about gravitational collapse? That's the source of heat from the sun versus having fusion there.
Okay, the problem with the nuclear theory for the energy of the sun is that the byproducts of that should produce copious quantities of neutrinos, and they are not observed. The amount of neutrinos that we observe is not sufficient to provide the energy to run the sun. We do observe some, so I'm not saying there's nothing going on there, but it's not sufficient. It appears that the force of gravity is the primary source of energy for the sun, and so it is causing the heating of the sun.
Well, is it gravitational collapse? Is the sun shrinking or getting bigger?
It's the sun is shrinking as the gravity collapses it in the center. The expansion is not. It's becoming less. I don't know how to say that. I guess you could say that because the sun, it isn't using up the material in the center of the sun, causing it to collapse. But it is true that I think there have been measurements that the sun is decreasing slightly in size. This mechanism that we're giving works well for a planet, and the sun should be changing size. But I think there should be some expansion on the surface. Maybe that expansion has already occurred, and we just don't see the material there anymore. Other questions?
Of the gas planets, Jupiter and Saturn, wouldn't they be either expanding or contracting based on expansion idea? Would they be expanding?
Yeah, so all the planets that we can see the surface of show evidence of expansion. I showed the pictures of them, and the moon that we can get a good picture of. We see expansion, but those are more solid. Where the Earth has a source of energy in the center. We don't know for sure what is there. If it comes from a star, the remnants of a star, then there could be some nuclear processes occurring in the center. We do know. I think that we mismodel the sun when we think it's old. If we thought the sun was only 6,000 years old, our ideas about what produces energy in it would probably be quite different. For instance, the Earth, if we go backwards, when it was more massive, it would have had, if it had the same kinetic energy, it would have been closer to the sun. So if you track it backwards very far, it will become too close to the sun and too hot to support any kind of life. So if you have a good handle on the decay curve for the force of gravity, and I think it's a fairly simple calculation to do that. I haven't done it, but it's similar to a lot of other problems that have been solved in physics, and I think the same technique can be used to get the curve. It probably will end up being something close to an exponential curve. So that means that it would have decayed faster in the past than it is now. So if we go very far back in the past, we'd be a lot closer to the sun. And as you know, the current distance of the Earth and the sun is ideal for life at the moment. If it was too much closer to the sun, we wouldn't have life as we know it on the Earth.
It would have been closer because it was more massive in the past? Is that the reason why it would have been closer?
Right. And so and as its mass decays and the mass of the sun decays, then the force of gravity is not strong enough to hold it in a closer orbit, so it moves out into a larger orbit. And all the planets move out into larger orbit. We use ring lasers, and we easily measure to 2 or 3 significant figures the rate of slowdown of the Earth. The Earth does not slow down smoothly. It's got bumps in it. I don't know how to say it. There's something interfering with it due to either masses of something underneath the surface of the Earth or currents or something underneath the surface of the Earth that are interfering with the smooth slow down of rate of rotation. But there are you can go on the internet and you can find plots of the rate of the slowdown of the rotation of the Earth, and you can draw a curve through it. It's definitely decaying over time. It's not decaying real fast at the present time, but we can measure the rate to a number of significant figures. If you take that current rate and project backwards and say, how fast would it have rotated in the past? The answer is that if you go back like 100,000 years or something on that order, that the Earth would rotate so fast we'd get a bulge at the equator. So I think you can put more stringent, particularly if you have the force of gravity decaying, causing this expansion and the slowdown. It would rotate faster the farther back in time you went, and so the question is how much faster. Well, I don't think it was. If it was constant, and the Earth is only 6,000 years old, then or 10,000 years old, then it didn't rotate but 30% or 20% faster than it does today. But if the Earth was decaying and was significantly smaller, then you could say, yeah, it might have rotated 2 or 3 times as fast as it does today.
Dr. Lucas, given your model of the expansion of the Earth, the thinning of the atmosphere, and the changing solar output, have you given any thought to the current debate on global warming and how that could affect what we're measuring in terms of warming and future projections?
Well, I was this winter in Ukraine, and they told me, bring your warmest clothes. It's cold in Ukraine because it's pretty far north. And so I went there. I had all my heavy coats, and I just wore my suit jacket. They were in the middle of an extremely warm winter. The snow melted 2 months earlier than normal, and it melted just before I got there, and I didn't need a heavy coat. And they told me that this is the warmest winter in many, many years they'd had. They believe in global warming. But I would say this expansion of the Earth and the thinning of the atmosphere is what protects the surface of the Earth from the energy of the sun. And as it thins, the surface of the Earth will get warmer, just due to the thinning of the atmosphere. So this mechanism says you would expect global warming.
One other question. I just saw today in a news report that the standard for the kilogram, which is housed in a special vault in England somewhere, has lost 50 micrograms since it was put away for safekeeping, and they're puzzled as to what's causing the loss of mass, in this piece of metal. Do you have any understanding of that?
Well, there's a number of things at issue here. One is how do you measure the change in your standard? What is your standard to measure the change in your standard? One of the problems in physics is that the standards are all interlocking. In other words, if the mass of everything decays at approximately the same rate, you might not be able to detect it. You know what I mean? We detect things in a relative manner, and so like how do I determine the amount I weigh on a scale? I'm using the mass of the Earth and the force of gravity to do that. So if I'm losing mass and the Earth is losing mass, then the force that's pushing down this spring will say I'm getting lighter.
I believe they compared it to some 10 or 20 secondary standards.
Yeah, there's copies of the same thing with the same mass, and this is the only one that lost 50 micrograms.
So all the
Right.
copies they averaged out, and the
Right.
original one is lighter than the average of all the copies.
Okay, so I would say the rate of decay of the mass of those would depend on where they were. The one that was at a smaller radius from the center of the Earth than the one that was at a higher radius from the center of the Earth, the one at the higher radius would decay faster than the one below. And I suspect that they cannot, they might be able to detect the difference in the decay of two standard masses stored at different elevations, but if they had two side by side, they probably couldn't detect that they had changed. I don't know. I haven't really studied that, but all of the consistency says that if we have an independent way of measuring the mass of something, we should be able to detect its decay over time. And the fact that we can detect the expansion rate of the Earth, we can detect the slowdown of the rotation rate due to the expansion, gives hope that we could even detect the change in the mass of something. I think the rate, like for instance, if the radius of the Earth is changing by a few inches a year out of 2,400 miles, if we have something that's equally accurate that can measure the mass of something, we should be able to see that fractional change.
Do I understand you right? As the constant speed of light is relative to the proximity of the center of the universe, then?
Well, I'm suggesting that because you see these. If you looked at that picture with the iron filings, if you were to take those iron filings away and put them down again, they'd make the same pattern. And so it looks like there are what we used to be called lines of force in the field that accumulates these filings. And the idea is that if you think of little microscopic lines in the field, that when a photon goes out, it's wiggling this line of electromagnetic field, and there's a tension in that line, and it's easier for it to wave if it's all out by itself in the universe and nothing around it. But if it's next to another charged particle, well, the two field lines will interact, and it'll be harder to wave the field line of the first one with the second one being there. It'll have to move it aside, and so it will slow it down. It will impede its progress. And so the idea is that there's resistance the more matter you have close to the photon that's trying to move out. So that concept would give you the notion that the velocity of light would be slowest at the center of the universe and slowly get faster as you go out toward the edge. But if you stay at the same place in the universe, that argument wouldn't tell you that it's changing, but the fact that the oscillations and stuff like that are decaying for matter might interfere with the velocity of light also. I don't know what the effect is.
Dr. Lucas, we're getting very close to the end of time here. I want to thank you for the time that you spent. I think hopefully we'll work a little harder to have you come and participate in a conference and get some more of your information. So we appreciate your time here, and we will talk to you some other time.
Okay, and you can disseminate among your group those 2 PDF papers I sent you.
Right.
That's on the CD that Daryl has. And as my wife says, my writing is much better than my presenting, so you'll find it much easier to follow, and you might want to look through those. They're in color, and they can be seen best on a computer, or if you have a color printer, you can print them.